This video is on how to choose which method to solve systems of equations that are not linear. Or we'll just take a look at all the situations that aren't linear. Okay, we're going to use the same methods. We're going to use elimination, substitution. We can also use graphing. You could graph this on Desmos or on a graphing calculator and find the intersection. Sometimes that goes well. Sometimes that's a little more complicated. So we're going to look through how do we do it by hand. So the first section here, we're just going to talk about methods, and then I'll do a couple other videos on how to do the other things. So here we go. So first thing that you look for in these kind of situations is, do they have the same exponents? And if they don't have the same exponents, this is going to be a substitution problem. I'm going to have to solve the bottom equation for x or y and plug it into the top one because nothing's going to cancel out by adding. So if the exponents aren't the same or they aren't the same kind of thing, we have to use substitution. This second situation, that's what we were just talking about. Their exponents aren't the same, so this one's going to be substitution, and I would do like y equals x plus 1, and I'd plug that in the y spot and solve that out. So this one is also substitution. This third one, the best choice would be elimination. If I would multiply the top equation by -1, my x squareds would cancel out, and I would end up with just y's and numbers, and it would end up being a factoring problem. So this one we're going to use elimination. So if the variables have the same exponents, we want to use elimination. Same thing with number 17. I have the same exponent. I would multiply the top by -2 and use elimination. Number 37. Some of you guys will be a little nervous about this one because we got fractions, but the same kind of idea. They have the same exponents. So I'm going to use elimination. I have a 2 and a 3 and a 5 and a 2. So you're thinking, even though they're the top of a fraction, what's the common denominator for that part? So the common denominator between 3 and 2 would be 6. So I multiply the top by 3 and the bottom by -2, and they would cancel out, and I could go ahead and use elimination. Number 40, exponents are not the same. So this one's going to be a little bit more difficult. So what we need to do is solve it and use substitution. In this one, I don't want to break up this xy. That's going to get to be a little sloppy. So what I would like to do is solve the top equation for y. So I'm going to do y equals x cubed, and then I would substitute it in the second part and do that. So this one is a substitution problem. Number 47. This one I got logs. This one we call it, some people call it equal values. It's a substitution problem. I'm just going to set both halves equal. So log 2 x plus 4, and we're going to set that equal to 2 minus log 2 x plus 1, and I would solve that out using the opposite of logs, or so it'd be exponentials. But the original problem is going to be substitution. The last problem here, if you have a systems of 3 equations, this one we're going to use a matrix to solve. It would be a lot faster, use a matrix and a calculator to do that. If it does end up being same line, or um, if they have no solution, then you're going to have to finish it by hand to double check which one that is. But that's how you go about figuring out which type to do. The next video will be how to actually do the calculations.